Geomorphology is the study of Earth's surface, its landforms, and the processes that shape them. And as a result, the landscapes of Earth's surface are really a critical piece in understanding this whole interconnected system, the evolution of Earth's surface, and then how individual landforms that we might be interested in, be they valleys or dunes, are actually shaping and evolving themselves in concert with the Earth system and changing climate and tectonics. So the goal of this lecture is just to give you a few slides and thoughts about real landscapes, natural landscapes, and to start looking critically at Earth's surface and trying to pick out details of what you see, of what might be changing, what might be staying the same, and what might look just either out of place or in place. And over the course of this class, I think you're going to get a better sense of that. So just first up, what do we see in this photo? So we're going to go around a little bit, right? And so in the back, obviously you see some big snowy mountains, and then some lower mountains in front of them, and in the foreground we see this very dry hill up here on the left-hand side. In the foreground, there's this vegetated bar, and the kind of green vegetation that's on this bar is totally different from what we see with this zone back here where there's no vegetation, or this surface back here, so this high flat surface that we call a terrace, which is an abandoned river floodplain as the river cuts down. In the foreground is, of course, the modern flowing channel. You might ask yourself a few questions, right? So why does this river look this way? Where is the water coming from? How do we have this much water in the desert? And why is it green by the river and brown farther away, and then bright and snowy even farther away from that? Answers to that might be found in the hydrological cycle and the way that water flows through the landscape and under the surface. So for example, these gravels in the bar are able to transmit water very easily through large pores, and that supplies water to these bushes that you see. This terrace over here, well, we can't see the surface very well, but it's higher and it looks drier, and this hill is definitely higher and drier. Up here in the mountains, there's simply a lot lower temperature, right? And so the snow is actually able to stay there for much longer. And so what we see here in this picture is a set of different topographies that are linked to the water cycle. And then what we can also view in this image is the fact that we're going from essentially new topography, fairly recently built topography created by tectonics and erosive processes, maybe glacial erosion and maybe fluvial or river erosion. And then in the foreground, what we see is the river today as it's moving in the foreland of the mountain belt. So we might have some hills that look more like those on the left over here, which are these very, very steep walled bedrock hills that in this case are in Utah. And then we also have these hills that are kind of angular and have a crest and have overall lower relief, and that's an example of the Loess Hills in Iowa. And so I want you to think a little bit about what's shaping these, and the fact that perhaps the sandstone on the left is a lot more competent and has a lot more cohesive strength than over on the right, where you see the Loess Hills in Iowa, which are made of loess, that's fine-grained, wind-blown silt. Over on the left here again, we have the Missouri River, as well as on the right, but there are two very, very different versions of the Missouri River. And so again, just like look at that. Think about what's carving those bedrock banks, how maybe the bends in the river are causing the flow to be able to cut into the bedrock and erode material away, how the river bends might be relating to the forest and the ecology on either side, regardless of whether we're talking about the Missouri River all the way up near its headwaters on the left, or farther downstream on the right. And the other thing to think about is at some point, this river goes from being a steep, bedrock-dominated watercourse into this very, very wide lowland riverway that is surrounded by these agriculturally productive lands and floodplains. And so what is it over the course of the river and the course of the water and sediment continuity? through the fluvial system that's actually changing this and causing these landforms to form themselves, in fact. And so there are questions that we can ask about this related to processes as well. So for example, how does our understanding of these processes on Earth's surface help us to predict erosion and deposition and other changes that might impact ecosystems and natural resources? And so here we're seeing erosion of the small zone in a gully. There are different trees. You can see the bases of the trees like this over here with the root balls on this side that have all toppled in to this eroded out little hollow. And so how might surface water or groundwater or processes of brittle failure or viscous failure perhaps, how might these different processes have changed this hill slope and caused these slopes to evolve over time? And how might human activities affect the amount of runoff and water that these watersheds receive, and therefore affect erosion and eventually sediment delivery to downstream river systems, which could change channel form or impact water quality? Of course, these rivers and all the eroded sediment and material reaches the coast at some point, and then the material from the rivers can interact with tides and waves to create these really exciting looking landforms, especially someone from the Midwest where I only really see these on lakes. And so on the right hand side you can see these spits that are formed by overall longshore drift. So in this image the current is going from the top of the image to closer to the camera, and this is moving sand around and depositing it in these eddies. And so there's an interaction between sediment erosion, sediment deposition, and flow, where patterns of flow affect erosion and deposition and change the landscape. And then the landscape change by formation of these barrier islands and spits actually affects the geometry of the sea, of the shore interface, which then can impact how the sediment is able to be transported because it changes the flow field. So this two-way interaction is really key in these nonlinear feedbacks. And when I say nonlinear, I mean one thing affects another one, the other one feeds back and affects that first one, and it's not a simple one-to-one relationship. They actually really fundamentally change those processes. So we really want to understand how these sorts of systems work. And the coastlines are especially important as we dam rivers and as sea level rises due to an overall warming world, thermal expansion of water, and melting ice sheets and glaciers. Of course, we can look at the places that are very different from the sea, but we can still see some familiar shapes, right? There are ripples and dunes in these longshore drifts. And here in this image in Oman, we can see similar dune shapes and landforms, except these are all windblown. And so what is it that creates an environment that is arid enough to release all of this sediment, and what causes the sediment to self-organize? And furthermore, is there something about sand supply, maybe from a sandstone, for example, or from windblown material from elsewhere in the world, that can cause there to be a place that is full of these dunes, whereas some other deserts might be rocky and dry? And so here's an example on Mars. And we can see the very similar dunes up here on Mars as we see in Oman. And so what is it that makes a place like Mars, which has so much less gravity than Earth, actually a comparable, create comparable landforms? They also don't have as much atmosphere as we do. So despite that, these systems look very, very similar. And so overall, and here's a map of North America on the right, the topography, I want you to think about why some places are steep and why other places are flat. Why are lakes and rivers located where they are, and what does that tell us about how the landscape might have looked in the past, how it evolved from past to present, and how it might look in the future? And so that's everything I have for you right now. The main feature that I want to just bring up is to think about landforms. How do landforms change? How do they evolve? And over the course of the semester, we're going to work through tools that will help you think about these systems and help you understand and predict landform change through time.